Here's the solution for day one. Use the law of cosines to solve the triangle. Here we have a triangle that's not a right triangle, so that's why we can't use just our basic trig definitions to get angles. And we don't know any angles to begin with, so we cannot use the law of sines because we don't know an angle measure and the length of the side opposite to set up those ratios. So we have to use the law of cosines to get started. Now we only need to do the law of cosines one time because that'll get us an angle measurement, and then we'll know enough information to use the law of sines. So I'm going to figure out angle A first, and I'm going to use the law of cosines formula that focuses on angle A. It looks like this. The cosine of angle A is equal to b squared plus c squared minus a squared, all divided by 2 times b times c. There are actually 3 different formulas for law of cosines, and each of those 3 formulas has 2 forms. One that focuses on side lengths and the other that focuses on angle measurements. So I'm choosing this one right here because this has the focus on angle A. Now let's make substitutions. The cosine of angle A is equal to 6 squared, because opposite capital B is where lowercase b is, plus 7 squared, because opposite from capital C is where the lowercase c is, minus 8 squared, because opposite from capital A would be the lowercase a. And that's all divided by 2 times 6 times 7. Now let's figure out what that makes on a calculator. 36 plus 49 take away 64 makes 21. And in the denominator, 2 times 6 times 7 is 84. And 21 over 84 is 1/4, or the decimal 0.25. Now that's what the cosine of angle A is. So to find the measure of angle A, we do inverse cosine. With my calculator in degree mode, when I do the inverse cosine of 0.25, I get 75.5 degrees. Now we're going to get angle B figured out. We could do the law of cosines again, choosing the formula that has cosine of capital B on the left side. But notice how much work that is to get an answer with law of cosines. The law of sines is much faster. So let's do the law of sines. The sine of angle A compares to the length of side A, as the sine of angle B compares to the length of side B. This proportion can be solved with the cross multiply technique. We'll get the sine of capital B is equal to 6 times the sine of 75.5 degrees divided by the 8. Take a calculator and type this in right here. And that makes 0.7261 if you keep 4 decimal places. This value is what the sine of angle B is equal to. To actually find angle B, we need to do inverse sine. And when I type this in the calculator, the result is 46.6 degrees. All right, we have one angle left to figure out, angle C. We could get angle C by using the law of cosines, or the law of sines, or the fastest way is to realize that all 3 angles add up to 180, and we already know 2 of them. So let's add those 2 known angles together and subtract from 180. And the result is 57.9 degrees.